All right, hello everyone, and welcome to the first of the video lecture series for Intermediate Algebra. We are going to be starting with the 6.1, which is the start of the chapter called Rational Expressions. So throughout this chapter, we are going to be learning all about what rational expressions are, and we will be performing operations on rational expressions, such as multiplication, addition, subtraction, and division. Now, before this video starts, I will say that I am doing the best that I can with the limited time and technology that I have at my disposal here at home. I am working with a very glitchy stylus that I'm using to write on these PowerPoints. So I apologize in advance for any weird things that happen with the stylus. All attempts so far at fixing it have failed, so we're going to do the best we can with what we have. The note outlines that go with each of these video lectures and PowerPoints are posted on Canvas, so make sure that you are following along with the video lecture and taking notes in the note outline as we usually do in class. Also, I apologize if the auto-generated subtitles do not always match what I am saying. Again, I'm doing the best I can with the technology at my disposal. So first, to get us started, what is a rational expression? So a rational expression is a fraction that contains a polynomial in both the numerator and denominator. So far in this course, we've been working with just polynomials, so we have not seen variables in the denominator. Rational expressions occur and are generated when you divide two polynomials and you write that division as a fraction. So when we did polynomial long division, we were sort of working with rational expressions without knowing it. So if you were to write that division as a fraction, you would have two rational expressions. Rational expressions always have a variable in the denominator. Rational expressions may or may not have variables in the numerator. And rational expressions can come in all shapes and sizes. Some are really simple, some are really complex, but rational expressions are fractions that always contain a variable in the denominator. Now, because rational expressions are fractions, they are going to follow all of the exact same rules as regular fractions. So all of the processes for regular fractions are going to be the same here with rational expressions. So when the numerator and the denominator contain no common factors other than 1, we say that the rational expression is fully reduced or reduced to lowest terms or simplified. So it's basically the same thing with regular fractions. If in a regular fraction there are no common factors on the top and the bottom, the fraction is fully reduced. Same thing with rational expressions. If there are no common factors between the numerator and denominator, the fraction is fully reduced. Now, all of the operations on rational expressions, such as addition, subtraction, multiplication, and division, those processes are going to be the exact same as those operations on regular fractions. So yes, eventually we will have to think about things like common denominators. That is what is coming later on in this chapter. These are all examples of rational expressions ranging from the very simple to the very complex. So we have 4 over x here is a rational expression because there is a variable x in the denominator, and for this rational expression there is no variable in the numerator. Now for this expression over here, 2x over x plus 1, there are variables on both the top and the bottom. So there is the polynomial 2x in the numerator and the polynomial x plus 1 in the denominator. So we have the quotient of two fractions written as, we have the quotient of two polynomials written as a fraction, so this is a rational expression. And then 2x squared minus 5x minus 2 over 14x to the 4th plus 5 is also a rational expression. We're going to start off with simplifying rational expressions because you should always make sure that your answer is fully reduced. Just like with regular fractions, you always needed to make sure that your final answer was fully reduced. Same thing here with rational expressions. So a few tips when you're simplifying rational expressions. Parentheses are your best friend. Also, factor everything. If anything looks even vaguely factorable, you're going to factor it. You should also look for GCFs. You should always look for GCFs when you're doing any sort of factoring, but especially here, if there's any factoring to do anywhere, please factor it. Even if it's just taking out a GCF, that might be enough. You should also remember your exponent rule, specifically the exponent rule that deals with quotients. So the quotient property of exponents, which is x to the a divided by x to the b. You might remember from chapter 4 that you can simplify this by subtracting the exponents. It'll simplify as x to the power of a minus b. You may need to use that once in a while. Now the thing is that when you're canceling out common factors, you can only cancel out common factors, not common terms. Common factors are matching sets of parentheses. Remember, when you factor an expression, you are writing it as a multiplication. As soon as it's written with multiplication, you are allowed to cancel out common factors when there's multiplication. Common factors would be sets of parentheses that are exactly the same. So you can only cancel things out when there's multiplication. You absolutely cannot, under any circumstances, cancel out terms across a plus sign or a minus sign. You cannot cancel out terms across addition or subtraction. So this is an example of a rational expression that we are going to simplify. So the first thing I'm going to do is, if anything looks factorable, I'm going to go ahead and factor it. Now the numerator x plus 6 here is not going to factor, but what I am going to do is I am going to put parentheses around it. Because anything that would cancel out with x plus 6 would have to be another matching set of parentheses that contains an x plus 6. Then in the denominator, I'm going to factor the denominator. So since the leading coefficient is 1, there is an x here and an x here. And we're looking for two numbers that multiply to negative 6 and add up to positive 5, which are plus 6 and minus 1. So then, now that you have written this as, Now that you have written this as multiplication, remember there is multiplication right there between those two factors, any common factors between the numerator and denominator can cancel each other out. Because remember the rule that anything divided by itself is 1. Also, when you cancel out common factors, they don't go away, they just become 1. So in the numerator we have this x plus 6, and in the denominator we have this x plus 6. Because these two sets of parentheses completely match, we can cancel them out. So we have x plus 6 divided by itself is 1. Then what we're going to do is we are just going to multiply what's left over. So in the numerator, what's left over is a 1. And then in the denominator, 1 times x minus 1 is x minus 1. The parentheses are optional here. You can keep them if you want. You can get rid of them if you want. If you want to stay in the good habit of keeping them, you are more than welcome to keep them. But since we have canceled out all of the common factors, this is now your final answer. Keep in mind, it is okay to drop a denominator if there's just a 1 left over. However, blank numerators are not okay. If there is nothing left in the numerator, there is a 1 in the numerator. Now, at any point during this PowerPoint, if you want to attempt a problem before I go over it, feel free to pause the video and then resume the video when you are finished. I am going to just go on through these next several examples, but feel free to pause at any time. So to simplify this expression, what I'm going to do is I'm going to factor anything that looks even vaguely factorable. So since the numerator is not going to factor any further than that, I am going to put parentheses around it. And then in the denominator, when I factor the denominator, because this is a 1x squared, there is an x here and an x here. And we are looking for two numbers that multiply to 25 and add up to negative 10, which is minus 5, and another minus 5. Now you do not have to write that denominator as x minus 5 squared because we are going to just be canceling out common factors, so you can just leave it like this. However, keep in mind that you can only cancel out common factors in pairs. 1 in the numerator and 1 in the denominator. So yes, there are a lot of x minus 5s here. However, you can only cancel out the x minus 5 in the numerator with one of the x minus 5s in the denominator, because you can only divide two things at a time. So this x minus 5 in the numerator can cancel out with either of these x minus 5s in the denominator. Doesn't matter which one. And then remember, when you cancel out common factors, anything divided by itself is 1, so they become 1. Then we're going to multiply what's left over. So what's left over in the numerator is 1. Over 1 times x minus 5 is x minus 5. The parentheses in the denominator are optional. And then this is now fully reduced. So then for this next one, there is a lot of factoring that it looks like we can do here. So I am going to factor the polynomial in the numerator and the polynomial in the denominator. So in the numerator, since this is a 1x squared, that means there is going to be an x here and an x here. And then we are looking for two numbers that multiply to positive 18 and add up to minus 11. Which are minus 9 and minus 2. Then in the denominator, because this is a 1x squared, there will be an x here and an x here. And we're looking for two numbers that multiply to negative 8 and add up to positive 2, which are plus 4 and minus 2. Then any common factors in the numerator can cancel out with common factors in the denominator. So this x minus 2 in the numerator can cancel out with this x minus 2 in the denominator. Now, for the x minus 9 and the x plus 4, those two sets of parentheses are not exactly the same. Therefore, they are not common factors, and therefore they cannot be canceled out. So we'll multiply what's left over in the numerators. X minus 9 times 1 is x minus 9. And then in the denominator, x plus 4 times 1 is x plus 4. Now, resist the urge to cancel out the x's. You cannot cancel out the x terms because those are common terms, not common factors. Common terms do not count, and common terms cannot be canceled out. So do not cancel out this x in the numerator with this x in the denominator. This is actually fully reduced, and so that is your final answer. We're going to do basically the same thing here. We are going to reduce this by factoring that polynomial in the numerator and factoring that polynomial in the denominator and looking for common factors. So when you factor the numerator, since that is a 1x squared, there is an x here and an x here. And we're looking for two numbers that multiply to positive 4 and add up to positive 4, which are plus 2 and plus 2. Then in the denominator, again, since that is a 1x squared, there will be an x here and an x here. And we're looking for two numbers that multiply to positive 2 and add up to 3, which are plus 2 and plus 1. Then, any common factors in the numerator can cancel out with any common factors in the denominator. Remember that you can only cancel out common factors in pairs, one factor in the numerator with one factor in the denominator. So this x plus 2 in the numerator can cancel out with this x plus 2 in the denominator. Now, the x plus 2 that's left over in the numerator cannot cancel out with the x plus 1 in the denominator. They could only cancel each other out if they are exactly the same and are truly common factors. So therefore, we're going to multiply what's left over in the numerator. 1 times x plus 2 is x plus 2. And then in the denominator, 1 times x plus 1 is x plus 1. Resist the urge to cancel out the x's because those are common terms, not common factors. So do not cancel out the x terms. Common terms do not count, only common factors count. And then for this one, when you go about the factoring for this next one, keep in mind that you should always look for greatest common factors whenever you are doing any sort of factoring. So the numerator is fully factored, so I'm just going to put parentheses around it, x minus 2. Then in the denominator, if you look between these two terms, you notice how they have a common factor. There is a greatest common factor of x squared. So I'm going to factor an x squared out of both terms, which then leaves us with x minus 2. Remember, when you factor out a GCF, you technically write it in front with multiplication. So because there is multiplication here, this x squared does count as a factor, and this x minus 2 also counts as a factor. Because there is multiplication in that denominator now you can think about canceling out common factors between the numerator and denominator. I wish there was a shortcut for this. So this x minus 2 in the numerator can cancel out with this x minus 2 in the denominator. Then once you cancel those out, remember blank numerators are not okay. It is not okay to have nothing in the numerator. So because when those canceled out they became 1, there's only a 1 left in the numerator. Then in the denominator, x squared times 1 is x squared. So 1 over x squared is now fully reduced and is your final answer. Now for this next one, we're going to run into a couple of problems with this next one. So remember, anything that looks even vaguely factorable, you're going to go ahead and try to factor. So in the numerator, there doesn't look like there's much to do. However, 8 and minus 2 are both divisible by 2. So there is a greatest common factor here of 2, and I'm going to factor out a 2 as a GCF. So then 8 divided by 2 is 4, and then negative 2x divided by 2 is minus x. Then in the denominator, because that is a 1x squared, there is an x here and an x here. And we're looking for two numbers that multiply to negative 12 and add up to negative 1, which are minus 4 and plus 3. Now, here's the thing. You can only cancel out common factors when the sets of parentheses are exactly the same. This 4 minus x in the numerator is not exactly the same with the x minus 4 in the denominator. However, if these two, the 4 and the x in the numerator, were switched, we could cancel them out. Now, order matters with subtraction, so you can't just change the order of subtraction. But what you can do is if you want to change the order of subtraction, you can, as long as you factor out a GCF of negative 1 first. So that's what I'm going to do. I'm going to factor out another GCF in the numerator, and I'm going to factor out a negative 1 out of both of these terms in the parentheses. So then 4 divided by negative 1 is negative 4. And then negative x divided by negative 1 is plus x. Now don't forget that the denominator is still there. We haven't done anything with it yet, so I'm just going to leave it alone. Now that doesn't look like it did much. However, there's addition here now. Order does not matter with addition, and you can change the order of addition. So that's what I'm going to do. So then 2 times negative 1 is negative 2. I'm going to swap the order of that addition to give us x plus negative 4. And then in the denominator, I still have this x minus 4 times x plus 3. Remember, you can't cancel them out until they completely match. However, in the numerator, adding a negative is the same as subtracting. So I'm just going to rewrite that x plus negative 4 as x minus 4. Then in the denominator, I have x minus 4 times x plus 3. Now that these two sets of parentheses completely match, now they count as common factors. Remember, there's multiplication there, so you are allowed to cancel these out because you are allowed to cancel out across multiplication. I'm going to cancel out this x minus 4 with this x minus 4. So then let's multiply what's left over in the numerators and the denominators. So in the numerator, we've got negative 2 times 1, which is negative 2. Over 1 times x plus 3 is x plus 3. You can leave the negative in the numerator if you want. It's not really a big deal. Another way that you could write this is you could put the negative off to the side, so you can write this as negative 2 over x plus 3. It doesn't really matter. It's the same thing. If there is a negative in a fraction somewhere, the whole fraction counts as negative, so if you want to leave it in the numerator or you want to put it off to the side, it doesn't really matter. It's the same thing. So then for this next one, keep in mind that we covered a bunch of special factoring cases, and this rational expression is going to involve one of them. So first step when you are simplifying a rational expression is to factor anything that looks even vaguely factorable. So in the numerator, I have this x squared minus 4. These are both perfect squares that are being subtracted, so the numerator is actually a difference of squares. So I'm going to factor this difference of squares as x minus 2 times x plus 2. Then in the denominator, because that is a 1x squared, there is going to be an x here and an x here. And we're looking for two numbers that multiply to negative 8 and add up to negative 2. So that is minus 4 and plus 2. Now that you have this factored and written with multiplication in the numerator and multiplication in the denominator, you can cancel out pairs of common factors between the numerator and denominator. So this x plus 2 is going to cancel out with this x plus 2. Now, let's multiply what's left over. So we've got x minus 2 times 1, which is x minus 2. Then in the denominator, x minus 4 times 1 is x minus 4. Do not cancel out this x in the numerator with this x in the denominator. They are common terms, not common factors. You cannot cancel common terms, so do not cancel anything more out. Also, 2 and 4 are common terms. You cannot reduce the 2 and the 4 to 1 over 2 because those are common terms. You cannot reduce common terms. So that is all the canceling out that you can do. That is all the simplifying that you can do. This is your final answer. If you would like to leave the parentheses there to make it clear to yourself that these are not common factors and you can do nothing more with this, please feel free to leave the parentheses there. Now, for this next one, before we really dive too deep into the factoring, I do want to point out this negative that is in front of the x squared. You might remember that if the leading coefficient is negative, your factoring is a lot harder. So when we covered this last time, if the x squared term is negative, what you need to do is you need to factor a negative 1 as a GCF first before any other factoring happens. So I'm going to factor out a negative 1 as a GCF first, just out of the numerator. I'm going to leave the denominator alone. I will get to that in a moment. But I am going to take a common factor of negative 1 out of every term in the numerator, which involves dividing every term in the numerator by negative 1. So negative x squared divided by negative 1 is positive x squared. 3x divided by negative 1 is negative 3x. And then positive 10 divided by negative 1 is negative 10. And then we're just going to leave that GCF where it was. You can leave it as a negative 1 or you can leave it as just a minus sign. It doesn't really matter. And then you're going to focus on factoring what's in the parentheses, the x squared minus 3x minus 10. So in the parentheses, now that that is a 1x squared, there is going to be an x here and an x here. And we are looking for two numbers that multiply to negative 10 and add up to negative 3, which are minus 5 and plus 2. Then in the denominator, since that is a 1x squared, there is going to be an x here and an x here, and you're looking for two numbers that multiply to -5 and add up to -4, which are -5 and +1. I'm very sorry about that. That's what I mean by I have a glitchy stylus, and there's nothing I can do about it. Anyways, so now that there's all multiplication here, remember there's technically multiplication there, and multiplication there, you can cancel out common factors between the numerator and denominator. So I'm going to cancel out this x minus 5 with this x minus 5. So then let's multiply what's left over. Now, because there's more in the numerator than just this x plus 2, we've still got this negative out here, you do need to leave the parentheses there. So I'm just going to stick the negative out in front here, and I'm going to leave the parentheses alone for x plus 2. Then in the denominator, you can leave the parentheses there if you want, but since x plus 1 is it in the denominator, they're optional. Now, this is fine. You can leave it like this, and I'm completely fine with that. Or another way that you can write this, you can distribute that negative into the numerator. If you want to, you can write it as negative x minus 2 over x plus 1. You don't have to do this. It's completely optional, but it is just another way that you can rewrite it. I promise that the easiest way to master this is to just do a whole bunch of them. And remember, if you want to attempt a problem before I go over it, just pause the video and then resume when you are finished. So for this next one, if you are simplifying a rational expression, I'm going to factor anything that looks like I can possibly factor it. So in the numerator, since that is a 1x squared, there's going to be an x here and an x here. And we're looking for two numbers that multiply to -15 and add up to +2, which are +5 and -3. Then in the denominator, because that is a 1x squared, there will be an x here and an x here. And then we're looking for two numbers that multiply to +12 and add up to -7, which are -4 and -3. Then you are going to cancel out any common factors between the numerator and denominator. So this x minus 3 is going to cancel out with this x minus 3. So then left over in the numerator, we have this x plus 5. Let's try that again. In the numerator, we have x plus 5, parentheses optional. And then in the denominator, we have this x minus 4, parentheses optional. Do not cancel out those x terms. They are common terms, not common factors. So then for this next one, remember, anytime that you see a negative x squared, your factoring is a lot harder if your leading coefficient is negative. So fix that for yourself by first factoring out a -1 as a GCF out of the numerator first. So in the numerator, I'm going to factor out a -1 out of each term in the numerator only. I'm leaving the denominator alone for right now. So negative x squared divided by -1 is positive x squared. And then 9 divided by -1 is -9. Then I'm just going to leave that GCF where it was. You can leave the 1 there if you want to, or you could just write it as a minus sign if you want to. It doesn't matter. The difference of squares in the numerator, x squared and minus 9, is a difference of squares. It is going to factor as x plus 3 times x minus 3. Then in the denominator, because that is a 1x squared, there is an x here and an x here. And then we're looking for two numbers that multiply to 12 and add up to -7, which are -4 and -3. Then any common factors in the numerator can cancel out with any common factors in the denominator. So this x minus 3 in the numerator can cancel out with this x minus 3 in the denominator. Now for what's left over in the numerator, because we had that GCF of -1, you do need parentheses around the numerator, so you do need to either leave it like this or distribute the negative. And then because x minus 4 is it in the denominator, it does not necessarily need parentheses, although you can keep them there. And again, this is completely fine for your final answer. If you want to distribute the negative in the numerator, you can also write it as negative x minus 3 over x minus 4. Now in this section, we are also going to be both multiplying rational expressions and dividing rational expressions. And the reason that we're going to jump right into the multiplying immediately after simplifying is because multiplication of fractions is not that much of a stretch beyond simplifying. And you're going to find that when you multiply